Hi everyone. So let's take a look at some exponents that we're going to work on today. Today we're working on solving exponents. That's an L. Now, we started off with this on our last lesson by saying, hey, what are exponents? And if I say, for instance, 4 squared is equal to 16, an exponent tells me how many times am I going to multiply that base value by itself. So since the exponent is 2, we're going to multiply it by twice by itself. Right? And 4 times 4 is 16. Easy peasy. If I make this up and I give you guys a variable, 4 to the x power is equal to 16, you have to think about what number times what number. In this case, 4 times 4 times 4 times 4 times 4. How many 4s will we need to get 16? And you can probably see that's 2. But I'm going to write this in a different way for you guys to think. If I have 4 to the x, could I write 16 as multiples of 4? So 4 times 4 is 16. Now I want you guys to write it this way. 4 squared is 16. We converted it to make this into a exponent with the same base. The key thing in us solving it this way is to have the same base. So you're 4, I'm 4. Now if you're 2, I also have to be 2. And what we do is we say x is equal to 2 now. Because the bases are the same, the exponents have to be the same now. And we can see x has to be 2. Let's go ahead and take a look at another example of this. What if I wrote this as 2 to the x power is 16? The base you can see is the number 2 now. Can I make 16 by a bunch of 2's? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So I would need 4 2's. So instead of writing 4 here, sure, we could write 4. I get that. X is 4. We got that, easy. But I want you to write this in a different way. I want you to say 2 to the x power, because we're trying to solve for x. But 16 can be rewritten as 2 to the 4th power. See, I changed the 16, the easy number, into an exponent with the same base. Now, since they have the same base, we can now say, hey, shouldn't x just be 4 now? And why am I having you guys thinking of it this way? Because sure, 2 to the x power might be easy, but I'm going to spin this around. Instead, I'm going to write, what is 2 to the x minus 4 equal to 16? Now, this problem becomes a lot harder for us to try to do in our brain. Okay, it's harder for us to just do in our brain. And you can start plugging numbers. You can say, okay, if x is 5 minus 4 is 1, 2 to the 1 is 2. Nope. 6 minus 4 is 2. 2 squared is not 16. 7. 7 minus 4 is 3. 2 cubed is 8, not 16. 8 minus 4 is 4. Oh, 2 to the 4 is 16. We could do it this way, sure. But that goes back to guess and check. And in algebra, our goal isn't to guess and check. Right? We want to have a method for solving this. So we could use logs. And we're going to learn how to use logs later. But right now, let's go ahead and look at an Algebra 1, Algebra 2 approach to this. Now that's change 16 to have a base of 2. So we said before, 16 is really 2 to the 4th power is equal to 2 to the x minus 4. Now please look at here. Here's a trick. This is like the SAT problem without using a calculator at all. No logs here. Just to say, I wrote them with the same base. Now if they have the same base, they should have the same exponent. I took off the warning. X equals to 8. And that's exactly the answer that we said we were going to have. Okay. So let's go and take a look at some other problems like this. If I say 16 equals to 64 to the x power, okay? Does 16, can I make 64 become a multiple of 16? And now this is a type of question that becomes tricky. Because before we were able to make our bases look alike, but I don't know that I can make 16 into 64, right? Give me 1 second. All right, so 16 equals to 64x. Now this one, if I multiply 16 times 16, that's way over, right? So we're going to have to play with this a little bit. Now instead, we can write this with a common exponent, maybe a 4 or maybe even a 2. A lot of different ways for us to get there. So let's use, can I get 4 times 4 times 4? That's 16 times 4 is 64. So let's use 4 then. 4 squared is equal to 4 cubed x. Now this takes us back to Algebra 1 and Algebra 2. What can I do with these numbers? So here's what we're going to do. 4 squared equals to 4 times 3x. We're multiplying powers. So here's what x is. 2 is equal to 3x. X is equal to 2 over 3. So now that we solve for x, let's double check if this actually works. 16 equals to 64, and with our exponent 2 over 3. So a couple things we need to remember is whenever we have a fraction exponent, that's actually a radical. So this is 16 equals to a cube root of 64 squared. And I don't want to square 64. I don't think you want to square 64, but we did realize that 64 is actually 4 cubed squared in terms of 4. If I multiply those out, we can do this a couple different ways. We could cancel these 3's out. We could have done that. I'm going to do it a long way so you guys can see the steps. We have the cube root of 3 times 2 is 6. So 4 to the 6th power. We can rewrite this as exponent, or we can just say we have 3 groups of 2. Right? And that's what the cube root is going to take out. Or you can rewrite it as a fraction, 6 over 3. That's 4 squared. So both these will give us the same answer here. And is 4 squared really the same as 16? Yes, it is. Yep, we're good to go. So would you have ever guessed that? Chances are yes and no, right? Yes and no. Some of these problems are more intuitive than others. Some are we can see them automatically, but we can't always see them. So because of that fact, we just have to have a method for us to be able to do these problems. Now, let me give you another problem now. This time, just to illustrate the fact that they can be fractions. If I say 36x equals to 6, okay? Now, maybe you have realized that the square root of 36 is 6, right? Square root of 36 is 6, and this is really 36 to the 1/2 power, rewriting this as a fractional exponent. So yeah, this is what it is. That works, right? But how would we have known that besides knowing this? So let's go ahead and rewrite this as, can I make 36 into the same base over here? So in this case, yes, I could make 36 into 6 squared x equals to 6. That's 6. 2 times x is 2x. 6 to the 1 power. And 2x is equal to 1. Solving for x, divide both sides by 2. X equals to 1/2. And that gives us the same answer we were hoping to get this other way. We can do a very similar problem. What if I went ahead and I gave you guys a more challenging exponent here? If I wrote 3x plus 3 equals to 6. We're stuck with the same problem. I can't think of any exponent of 36 that would bring it back down to 6. So I want to go ahead and rewrite this as a common base. That's 6 squared to the 3x plus 3 power equals to 6 to the 1 power. We're going to multiply those together. 6x plus 6 equals to 6 to the 1 power. And then we can say 6x plus 6 is equal to 1. Okay. Minus the 6 to both sides. 6x is equal to -5. Divide by 6 to both sides. X is equal to -5 over 6. Who would have ever thought that this would have worked? I mean, I wouldn't have guessed it. But let's go ahead and try plugging in and see if this is the number that would have worked. 36 to the -5 over 6. Oops, sorry, I need to multiply that by 3. I'm copying this problem over again. 3 times -5 over 6. Okay. plus 3. And will this give us a regular 6? Right, that we can simplify that. It's going to give us 36. 3 and the 6 divide out, leave me a 2. Negative 5 over 2. Now I'm going to change this to a fraction. 3 times 2 is 6. 6 over 2 is the same as 3. Subtracting those exponents from each other, 6 minus 5 is 1. And we are left with where we started on our last problem. And yes, the square root of 36 is 6. Okay, so we can use this method to solve more challenging questions, and we can get the same base. Then we can match the exponents, make them equal to each other, and then we can solve for the x. Okay. All right. So here's another problem. Let me go ahead and show you guys. What if they start off with a fraction? This problem goes 1 over 6 to the x plus 4 is equal to 6. Now how can I make 1 over 6 to become a regular 6? And how would exponents do that? Well, this takes us back to reminding us that if I have a negative exponent, if I say 1 over x is the same as x to the negative 1 power. 1 over 2 is the same as 2 to the negative 1 power. 1 over 10 is the same as 10 to the negative 1 power. So what I'm going to do is I'm going to try to get the bases to be exactly the same. So to rewrite this base first, this is going to be 6 to the negative 1 power. We have the exponent x plus 4 still is equal to 6. Now, just like what we did before, we're going to multiply our exponents out. 6 to the negative x minus 4 is equal to 6 to the 1 power. Now, since we have the same base, we can make the exponents equal to each other. And then we can solve both sides. Negative x is equal to 5. And we're going to move the negative over to become negative 5. X is negative 5. Do you believe that? Well, let's go ahead and plug it in. 1 over 6 to the plugging in x is negative 5. So it's negative 5 plus 4. And would this really give us 6? Rewriting it 1 over 6. Negative 5 plus 4 is negative 1. This allows us to flip it to become 6 is equal to 6. Yep, that would have worked. The last thing for today's activity is for us to go back and talk about change of base. When we come to change of base, we said this is one way for us to change our logs so that we could use a calculator, for instance. I call this a calculator log. So if I write log base 2 of 3, we said we could write this as two separate logs. Log of 3 over log of 2, right? This goes to the bottom, this goes to the top. Now, for natural logs, if you remember, a natural log is another way of saying log base e. Okay, log with our base is not a regular number, it's this irrational e value. To rewrite this is also log of x over log of e. E is a constant, is like the number pi. It's e is approximately like 2.7 blah 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 blah. So if I ask you guys in the IXL to practice this, they'll ask you, friends, what's natural log of 6, let's say? To rewrite this using change of base, this is really log of 6 over log of e. Why? Because natural log is really a fancy way of just writing log base e of 6. So 6 goes on top, and e goes on bottom. Log of 6 log of e. And so when I'm dividing logs, I'm really changing the base. Now just to give you one more. If I write just log, a regular log, let's say of 6, this log here is what we call a common log. So this is going to be log of 6 over log base 10. And of course, these are actually base 10 because when you don't write anything, it's base 10. In case we ever have to rewrite it. All right, and that's it.